We've taken a look at how we're going to work with Boolean circuits and how to convert those to tables, input-output tables, and then also how to convert them into Boolean statements. So let's take a look at tables and how we can kind of work that way to be able to take a table and to be able to convert that into a Boolean circuit. So one of the things that we like to do is we like to ignore any row that has a 0 in it. So don't even worry about these rows, all right, that has an output of 0. All we're worried about is the rows that have a 1. And those are the ones that we really want to work, and that's called a recognizer. So a recognizer is in any row that has a 1 in it. And all we're going to do is we're just going to build P and Q, and anywhere we see a 0, we're just going to put a 9. All right, so let's take a look at this first row. Okay, I'm going to designate that with the orange marker, and that has 1, 0. So we have our P and we have our Q. And we have a not that we're going to put on the Q because of the 0. Right, so what I'm going to do is I'm just going to draw Q a little bit, and I'm going to put a not here. And I'm going to connect those with an and. Right? And think about what happens if you throw a 1, 0 through that gate. So a 1, 0, the 0 becomes a 1, 1 and 1 becomes a 1. All right, so that's good output. All right, now let's take care of the other row that has a 1 in red. Right? And that's the 0, 0. So what I'm going to do is I'm just going to branch off of P, and I'm going to branch off of Q. And notice that they both have zeros. So what I'm going to do is I'm going to use a not on the P, and I'm going to use a not on the Q, and I'm going to connect those with an and. All right, now check this out. Let's say we put 0, 0 through. All right, well, if it happens here, this becomes a 0 right away. But if we put 0, 0 through this part, the output is going to be a 1. And we want 1 to happen for either of the two cases that we just developed. So what we're going to do is we're going to connect all of these, or both of these, excuse me, with an OR gate. So let's connect both of these with just a big old OR gate. Let's try to pass through, and this is going to be the final example that we work with this circuit. Let's try to put a 1, 1 through and see what happens, because the output should be a 0. So if I put 1, 1 through here, well, this 1 becomes a 0, and right away we get 0. And if we put 1, 1 through here, we automatically get a 0. And 0 or 0 is 0. So that's good that we got a 0 through that. And so that's the way that we're going to proceed to be able to develop these circuits from an input-output table. Right? So our answer would look something like this. You can draw it in one color when you draw it. I don't really care. Okay. A secondary example. Now this time we have 3 inputs. We have P, Q, and R, and we have 3 outputs that have recognizers. All right. So let's right away, let's just get rid of all the rows that have zeros in them. We don't care about those. All right. Those don't help us to be able to create our circuit. And just like we did before, we're going to have the inputs, which in this case are P, Q, R. And notice that in the first row, which I'm going to draw in black, 1, 1, 1, they're all just ones. So we want 1 and 1 and 1. And if all that occurs, our output should be a 1, which is true. All right, so that takes care of that row. Now let's draw the other row, and I'm going to do this in orange, is that P should have a 0 on it, or a not. All right, so here's what I'm going to do. I'm going to branch off of this, and I'm just going to draw a not right here. And the other two, I'm just going to draw like this. And once again, I'm going to connect those with an and. And of course, if you don't trust me that this is the correct answer, what you could do is you could just go ahead and pass anything else through that to see if it works. Now, the last row is we have a 0 on P and a 0 on Q. And so I'm just going to branch off of this. So P is this one. And I'm going to have a not. And I'm going to have a not on the Q. This is our Q. And then finally off the R, nothing. And we're going to connect all of those with an and. And then finally, we're going to connect everything with a big old OR. All right, and you want to make sure that it actually reaches the circuit. All right. A suggestion might be, after you're done constructing your circuit, is to pass something through that doesn't work, like 0, 0, 0 or 0, 1, 1, just, or I'm sorry, 0, 1, 0. Just randomly pick something that you know doesn't work or has a 0 as the output and see if it works, okay? And if it doesn't, then you might have to go back and reconstruct. All right. Let's go ahead and construct a Boolean circuit, or I'm sorry, a circuit from a Boolean expression in this example. And similar to what we did before, what we're going to do is we're just going to start inside parentheses, and we're going to kind of grow our circuit from there. All right, so in the first set of parentheses, we have P and Q, and not Q. So we have a P, and we have a Q. We're going to put a not on the Q. And those are going to be conjoined by an and. Right, so we have P and not Q. Now we're still going to work inside parentheses. We're going to work inside this set, but now we have a new variable R. So I have an R here. I'm going to branch off of the P, and the P is going to get a not. And the R is just by itself, and we're going to connect these two with an OR. And so that takes care of this one. This one's taken care of. And notice that those are conjoined with an OR statement. Okay, so right here, I'm just going to conjoin those two with one final OR. All right. So again, work inside the parentheses to the outside. All right. One last example of being able to work with these Boolean expressions and converting them into a circuit. All right. So we have this big guy right here. All right. So again, we're going to start inside the parentheses, and we're going to start at the leftmost parentheses. So we have a Q that's not, and we have a T. And it doesn't matter what order you do these in. So this is a Q, and this is a T, and it's going to be conjoined by an and. Right? We have not P or R. So we have P, and we have R. And this gets a not on it because it's not P. And we have an R that's being conjoined by an OR. Now notice still in, so that takes care of this and this. We have an and that we're going to connect these with. But then also we have to take care of this animal. Okay, so right now we've taken care of the largest set of parentheses. So we have a P or not T. Right? So we're just going to branch off of the T, and we're going to branch off of the P, and it's going to be a not T. So we're just going to put a not here. And we have the P, it's conjoined by an OR. And then finally, everything is going to get connected by the final OR. Right? So right here, that's the OR. All right, so that's what our circuit looks like. Right? Probably is going to look a lot nicer on your paper because you're not trying to write on a digital screen like I am. All right, so a couple more examples that we're going to look at in the next video with respect to circuits is just verifying that two circuits are logically equivalent. Right? But for right now, make sure that you're okay converting back and forth between the different mechanisms that we just looked at. So if I give you a table, make sure you can make a circuit out of it. And if I give you an expression, make sure you can make a circuit out.